Okay, welcome back to the Dublin Academy of Maths. My name is Mick Dalton and I'm doing Leaving Cert Ordinary Level Maths, Series 3, Episode 4. I'm on Paper 1 and it's Calculus. Now we've been doing all the rules and the last rule to do is the chain rule. Okay, now the chain rule consists of something to the power of something. Okay, now it's kind of iffy, so you can get multiples. Okay, you can get these types. So I'm going to try and successfully show you how to do these. Right. So the chain rule is really another composite function, and it just requires a bit of use in the head. Okay, so for example, y is equal to u to the power of n. Now u can be anything. Okay, and to get the derivative of this, we need to dy du. We need to multiply u and then reduce the power by 1 and then multiply by the inside of the derivative of the bracket. Okay, so that doesn't really mean a lot to you, but we'll do a question. So for example, this is a question and it says find dy dx. Okay, dy du we'll call it, okay, because we'll stick to this. This is u. Okay, so u is equal to this, 3x minus 1. U is equal to 3x minus 1. So what do we do? Well, we multiply by the power and reduce the power by 1. So it's 5 times 3x minus 1, reduce the power by 1. So that's 4. And multiplied by the derivative of the inside of u. So du dx is 3. Okay, times 3, because 1 is a constant. Did you see that? Okay, so you're getting the derivative of the inside of this and you're multiplying by the derivative. As the formula says up here, this is the rule. Okay, now it hasn't been written in the log tables, but that's how you do it. Okay, so you'd end up with 15 times 3x minus 1 to the power of 4. Okay, so remember that u is equal to 3x minus 1, du dx is equal to 3, and we put that in here. Okay, right. Let's have another look at another one. A composite one now. This is different. Well, it's the same. X minus 1 squared times x squared plus 3x. Now, again, this is u and this is v. This is like a product rule, okay? But first of all, we have to get. So we'll write out what u is. U is equal to. This is the way I prefer to do it, x minus 1 to be squared. Okay, we'll get rid of the grain. du dx is equal to 2 times x minus 1 reduced to power by 1, and it's 1. Okay? V is equal to x squared plus 3x. Okay? Now I have to get the derivative of this. So dx is equal to 2x plus 3. Now you're doing this along with me, okay? Now back over to this question, and I use these parts to get to the derivative of this. Okay, so dy dx with respect to x is equal to, using the product rule, u times dv dx minus v times du dx, okay, minus plus, sorry, we're using the product rule. Okay, so I'm going back to my product rule because I've got one by the other. Okay, so now I know I can put them in. Okay, so u is x minus 1 to be squared times dv dx. dv dx is 2x plus 3. Okay, so it's a big long formula. Plus v, which is x squared plus 3x times du dx. Okay, so here's the rule here. Du dx is x minus 1 to be squared, and the derivative of that is, which we've done, is 2 times x minus 1. Okay, we'll just, I hope you can see that now. Okay, so we've plotted that du dx into here, and we get a long formula here. And it's 2 times x, everything is okay here. And we work out this formula, okay? Now, there's not a lot to be done here, but I can see 2 times x minus 1 and x minus 1 to be squared here. I can possibly factorise them out. Well, anyway, I multiply them out and I can factorise them out, but really you could leave it just as that, okay? There doesn't seem to be anything I can do here. I can end up with something like this. If I factorise it out, I ended up with, I did the sum later and I ended up with this. Now, if you can do this, that's the factor. I brought out x minus 1 as a factor, okay? And I multiplied these out. Now, but I would normally leave it at this, okay, if it's too confusing. But anyway, you don't get any extra points as far as I see. Maybe if you might get 1 or 2. But remember that you're using, not only are you using the chain rule, okay, but you're also, because it's a product of one or the other, you must use the product rule, okay? And so that's really it. The v times the u dx, and you take out your parts, okay? These are by parts. You take out v and you get the derivative of v, dv dx, okay? Now we'll go across and we'll see if we can do a few questions here. Have a look at the questions. Now, these questions are fine, but these questions will use that method there, okay? And by the time you're finished doing these questions, you will have a better grasp on how to do the chain rule, okay? Now it's quite, everything is okay. So we have here, what, for example, this one here would be, if you just rub that out a bit, look at the rule. So we've got 2x plus, so I'm going to make u is equal to 2x plus 1, du dx is equal to 2, then we've got v is equal to x squared plus 3 all to the power of 3. We do the chain rule here, we do the, so dx, so you multiply by the power 3 times and reduce the power by 1, power 2, multiplied by the derivative of the inside, which is 2x, okay? And that ends up, as trying to clean it up, 6x times x squared plus 3 all to the power 2. That's the answer to that one. Okay, so you see what you're doing here, you're combining your rules, okay? With the chain rule, because you've got one function against another, you must use the product rule, okay? And these are normal chain rules, okay? So that's great. Thank you to those questions.